Hello, everyone. We are starting on Lesson 8, Unit 3, the natural logarithm. So what is e, this weird squiggly e? Well, before we get into that, I'm going to give you a question, example 1. Suppose you invest $1 at 100% interest for 1 year, and then we're going to vary the compounding levels. What is the highest amount of money you can have after 1 year? So the formula is just the same compound interest formula. If you remember from grade 11, it's your principal value, which is $1, your initial amount, brackets 1 plus your interest rate, which in this case is 100%. So 100% in terms of decimal value, it's just 1 over the compounding period, which is n, and into the brackets exponent n, which is your compounding period as well. So if we compound once a year, your amount of money that you will make is $2. So you just take 100% of the interest. So $1, it just doubles, and that's $2. That's it. What if you compound the interest semi-annually, meaning twice, meaning once at 6 months and again at the end? So your n value becomes 2. That becomes 1 plus 1 over 2, which is 1.5. And then you take 1.5 to the power of 2 and then times it by 1. And if you do that, you get 2.25. So if you compound it more frequently, you're going to make more money. You'll, realize that hopefully. So in this second scenario, we're making around $2.25. Now we're just going to keep doing that. We're going to keep going, and we're going to change our n value for 4. 1 over 4 to the power of, plus 1 to the power of 4 times 1, 2.44. Monthly, 12 times, then you get $2.61. Daily, 2.71. Secondly, meaning every second, if you were to compound, these are how many seconds are in a year. 31,536,000 times in a year. You will get a number that is close to 2.718281785. And finally, if we just do it bajillion, okay, no, not bajillion, what is that? 1 billion times? 1,000, 100,000, million. Yeah, 1 billion. And then we will get a value that is 2.718281827. So it's not really moving from this point. You can see that it's kind of honing in on this value here. This value is our E value. And what do I mean by that? The natural number E is a number like pi. You know, pi is like 3.14, 259, and so on. It's a number that kind of goes on forever. It continues, and it never repeats, and it's non-terminating. So just like pi, E is an irrational number. It's non-terminating and non-repeating. So it doesn't repeat. It's not a pattern. Not like 1 over 3, where it's just 0.33333. Like, that's a fraction. That's not an irrational number. That's a rational number. So this is a special number, and the way to solve it is to take the limit as n goes to infinity of 1 plus 1 over n to the power of n. And you get this value here. And obviously it continues. It's approximate because we can't have an exact value. There's no such thing. It just goes on forever. Now, what's important about this number? Well, a lot of naturally occurring phenomena can be modeled using the base E exponential and log functions. So you'll, I don't know if you've heard of like the golden ratio or anything like when it comes to naturally observed mathematical phenomena that's occurring in the world. Maybe I'll have a video on that for you guys to watch. It's just a cool, interesting, fun video. Not math related. But for us, we are going to be working with this value E. So if you want to approximate this, like 2.71828. I guess you can keep up to 5 decimal places. Log base E, X is known as the natural log. That's the third point here. And this can be written as ln x. So you know how log x is just log base 10 to the power of x? Well, when you have a log function that's base E, this natural number, that is called the natural logarithm, and it's written as ln x, ln(x). So there should be a button on your calculator, perhaps that's there, and that's what it means. It's ln x. It's just basically log base E. And something that you should know, that log base E is equal to ln E, and that's just 1. So ln, remember, is just the log base E. And if you're taking the log of the base value, and that same base value is there. Then they kind of cancel out and you're just left with 1. So the same basic log rules. Let us now go over, review some logarithmic rules just in case. So here's some reminders. Power law of logarithms. So log base b x to the power of n is equal to n log base b x. The exponent can be written in front, and this is just saying that b has to be bigger than 0, b cannot be 1, and x has to be bigger than 0. So you can't just destroy the whole thing by adding zeros. So yeah, exponent can just come in front. Product law of logs. So product law is if I have log base b brackets m times n, it's the same thing as if I want to split it up, just do log base b m plus log base b n. So you're adding them together. Same like the quotient law, where if you're dividing two things and within the same bracket, if you want to split it up into two separate terms, you can do log base b m minus log base b n. We have change of base formula, which we went over in a previous lesson. Log base b m is equal to log m over log b. This is very useful. This is what you use to solve a lot of problems in using your calculator when you don't have log of that base value. For example, if you have a question and it's asking for log base 2, 10, and the way to solve that, well, you don't have log base 2 in your calculator. The log button in your calculator is log base 10. That's kind of the generic, regular version. And if you want to do this, you're going to have to do this formula, which takes your m value, which in this case is 10, over log 2. And this is what that becomes. That's just 1 over log 2. But anyways. All right, and then we have exponential to logarithmic form. So we have y equals b to the power of x. That's an exponential form, which is equal now, x is equal to log base b y. So these are just, you're just changing it from forms and then changing, the opposite form, going from log form to exponential form. Y equals log base bx, and that goes to x is equal to b to the power of y. And other useful tips, if I have log base a and brackets a to the power of b, remember b can just go in front, and log base a just cancels out and it's 1, so that the answer is b. Log of a is equal to log base 10a. Remember, if there's no number written there, it's base 10. And log base b of b is equal to 1. It just cancels out and just left with 1. So some basic review. So let us now go over some practice problems. In this example here, we have our natural number e. Now in your calculator, you should be able to find this e. It looks exactly like that squiggly e. I'm not sure on your calculator how it would be, but in my calculator, it's there. And if you press that button, you should get a value of 2.71828 and so on. So yeah, so that's how you know you're doing it right. So hit that button, make it to the power of 3, and see what you get. So I'll do that to the power of 3, and I got 20 point, yeah, so this is the answer. Ln, once again, just get a good practice with this. Usually you have to do second function. Oh no, in my calculator I can just hit the ln button. So 10 and then ln, and then we got 2.3. Yeah, 30258. They rounded it to 2.303. And then ln of e, if you do that in your calculator, you should get 1, or you should just know that ln and e are kind of, going to cancel each other out and just give you 1. So some basic practice with your calculator there. Let us do another example. Oh wait, no, hold on. Let me get. Let's do this one here. So solve each of the following equations. So let's say if I have an equation where 20 is equal to 3 times e to the power of x. How do I solve for x? Well, the first thing I'm going to do is divide both sides by 3. So that's 20 over 3 is equal to e to the power of x. And 20 over 3, you can write that as a decimal, leave it as a fraction, that's fine. But now I'm going to take the ln of both sides. Why am I taking the ln of both sides? Because I want this natural number e to cancel out. So ln of e to the power of x, I know that ln e will cancel out, and this x just goes in front. So that's just going to be x is equal to ln of 20 over 3 And that's just a calculation in your calculator. And if you do it correctly, you should get something close to 1897. All right, that's it. What if we have an example where we have something like this? Okay, what do? Same thing. Take the ln of both sides. Take the ln of both sides. Remember, ln e will cancel out. This exponent comes in front. And then that exponent is just 1 minus 2x is equal to ln 55. And ln 55 is just a number in your calculator, which you can solve. And this is going to be 1 minus ln 55 is equal to 2x. What I did here was I moved the negative 2x on this side, and I moved the ln 55 on that side. So that's why ln 55 is now minus, and the 2x is positive. And we're just going to divide both sides by 2. And x is equal to 1 minus ln 55 over 2. That is just a calculation that you can use do in your calculator. And you get a value of negative 1.504. All right, basic stuff. And we'll do 2 more examples, and then we're going to stop there. Oh, actually, hold on. Let me do this. Okay. Here we have 2 ln x minus 3 minus 7 equals 3. So in this example, we have ln instead of e. So let's figure this out one step at a time. What I'm going to do is I'm going to move everything to one side. So this becomes 3 plus 7, so that's 10. I'm going to divide both sides by 2. So this becomes ln bracket x minus 3 is equal to 5. Now, what's the opposite of ln? It's raising everything with the base value of the natural number e. So I'm going to raise everything to the exponent level and then have my base value as e. And why I do this is because e and ln will cancel out, and this will leave me with x minus 3 is equal to e to the power of 5. And then x is equal to e to the power of 5 plus 3, because the minus became plus. And this is just a calculation in your calculator that you can do. And if you do that, e to the power of 5 plus 3, you should get something close to 151.413. That's it. And in this example, we have ln brackets 4e to the power of x. So what can we do here? What can we do here? Well, remember, if we want to get rid of the ln, we're going to take our e value and we're going to put it as our base number here and raise everything to the exponent form. Now this will cancel out, and now we're left with 4e x is equal to e to the power of 2. And now we have 2 terms of e, right? Well, what if I did e to the x is equal to e to the 2 divided by 4? If you haven't figured out, e to the 2 over 4, that's just a number. Sorry, my e looks a little wonky. And at this point, this is just a number. E squared over 4, it's some number, which you can figure out very easily. But my variable is in the exponent. And for me to kind of get it out of the exponent is to take the ln of both sides. If I take the ln of both sides, remember the x goes in front, this cancels out. X is equal to ln of e squared over 4. And you can just do that in your calculator. Let's plug it in. Remember to the inside first, so do e squared divided by 4 and then take the ln of that value. And if you do it correctly, you should get an answer of 0.614. That's it.